other rooms might develop hotspots. And so you have this constant struggle where despite the room showing red is warmer, the thermostat doesn't know the difference and therefore isn't cooling. Mm-hmm. And so this is actually a problem that Lester came up with. Apparently something that he and his wife have been struggling with for quite some time, and not a viable option in the market. So we felt it was a pretty good one to think about. So Lester's going to talk to you a little bit about AC, and just from a domain perspective, give you a quick overview, and then we'll talk about how we solve for this.
Okay, so there's supposed to be another picture here to the side of this, but I'll just have to talk through it, unfortunately.
It's kind of over Simon's head right there.
So normally when people think about air conditioning in their home, they think about this big unit outside, and they think that that's the end of the solution, but actually that's just the condenser. If you have an attic like me, you'll notice that there's actually a big blower in there that's actually moving the air, circulating the air throughout your house, and sucking in and moving air out. And if you look at that blower, you'll notice that there are several tubes or ducts running away from it that actually end up pushing air into vents in your home. So there's a duct attached to that output, right? And the air comes out. So we thought that one way to solve this problem, I thought it would be really nice if we could say, hey, this room is hot. Let's turn the AC unit on and get the air circulating again. However, one room is cold, so let's close the duct in the room that's perfectly fine temperature-wise, and let's move air to the room that actually needs it. So that's what we look to demo here today.
And that's really what we think is the innovation behind this, is that you have solutions like Nest and whatnot. It wouldn't be all that difficult to take what we've done and wire it up to the thermostat itself and just send an on signal when a threshold is hit. But we think that's a more complete solution because we're not only going to demonstrate that, but also the duct opening and closing as well. So in terms of the solution, so you remember the initial diagram only had the thermostat. So what we've done is added two sensors, or two controllers, or boards, excuse me. One is playing the role of sensor, and that's depicted by the purple. And that sensor is placed in the room where you're having the issues with heat, right? And there's a thermostat or thermometer sensor attached to that, which we'll look into here shortly. And then we have the actual controller, and the controller is basically just an aggregator of commands that will act on the thermostat or the AC thermostat itself to turn on or off the air, as well as the duct. And that is the killer solution that we think is pretty relevant here. So in terms of the architecture, we kind of broke up into sub teams, if you will. So I will let Mike talk about the sensor, since he did a lot of that work on the thermometer, and then we'll make our way through the stack.
Yeah, we have this temperature sensor on the left right there, which basically just senses the temperature, and it sends the current reading to the Azure queue, and then the Azure queue. Well, if the
maybe talk about the work within the sensor in terms of detecting the temperature and the thresholds, and then I'll take it from there.
Okay. So basically, we set the threshold to for the low it's 72, and for the high it's 76. So we can easily like switch it back and forth.
Great, yeah. So Mike did most of the work wiring up the breadboard and the algorithm for basically taking the current reading and then offsetting it, so it's about 10 degrees off. And so Sunny had a accurate thermometer that we used to gauge that. So basically backing that offset off, and then basically taking a continuous read of the temperature, which then we're taking and pushing into an Azure queue. So we created a queue on Windows Azure that basically is just a broker where these command messages are landing, and then the controller actually is doing most of the heavy lifting here. So the controller is not only grabbing those command messages, and that command message might be 1 or 0. So if the temperature has increased beyond that threshold, which is Mike said is 76 degrees, we're going to go ahead and send an on message, and the controller picks up that message and then talks to the relay, which is simulating the AC thermostat on command, as well as the servo, which is simulating the duct. And I'll let Joe talk a little bit more about that implementation.
So as you can see here, we've got our simulated duct, complete with the baffle inside there. And we've got the actual relay plugged in here, and that's all connected to the microcontroller. So when we receive the command off the actual Azure queue, if we're in an on state, then it's going to turn around and flip the actual relay, turn the air conditioning on, then also spin the duct. In this case, we're prototyping out here, but
The
you can
damper and
imagine
the duct, right?
the damper and the duct, correct.
Yeah,
You can imagine several of these inside that controller to where, maybe the room where the thermostat is, it's perfectly cool. We don't want this. We can actually shut off that duct so we get all the cold air pushed in the room that we're currently in. And the same thing, you turn the air conditioning on. That's pretty much it from that point.
Excellent, excellent. And yeah, again, Joe and Lester did a lot of most of the heavy lifting on the controller. So I think at this point, we can go ahead and demo. So I'm going to just switch here to Visual Studio. I'm not going to bore you with a bunch of code, but there's some feedback here that will be worth seeing. So what you can see right now is that we have a constant temperature read, and right now it's about just over 73 degrees ambient temperature in the room. And as Mike said, the trigger for basically sending a on command is 76 degrees. So there's a little sensor here on this there's a little temperature gauge on the sensor. So if I just touch it with my fingers, we should see
74.
that it's going up. My hands are usually hotter.
Oh no! Just dropped.
Put it in front of the.
Oh,
There we go.
So somehow it dropped.
Sweat.
There you go.
So there we go. So Sonny's a lot more warmer blooded than I am right now.
Hot-blooded, baby.
So
There we go.
boom.
The damper opened.
So you can see that
The
the
relay
relay
is
light
on.
is now on and the damper opened. And then since I'm apparently really cold blooded right now, maybe I should do the other one. But I'm just going to take a Sprite can here. And now I'm going to make the temperature drop to 72 or below. There we go. Come on.
Fix it up.
It is a demo, right?
There
we
Network connectivity.
So, any questions?
Awesome.
In a real system, wouldn't you have a couple of relays going to dampers to close one down, open another, and balance? a little bit?
Yeah, potentially. Yeah, for sure. So yeah, again, the servo, it works really well. So yeah, so the servo is just basically, simulating that, the opening and closing of the
As
duct.
soon as you said that, it turned.
Yeah. Yeah, we have a super
Voice
secret
cue.
voice actuator. That's
I have a
picking
quick
stuff up.
question, actually. How hard would it be to set up? Because the sun in that room over there.
So yeah, we all agreed that we're gonna split the partnership 4 ways, but actually it's gonna be skewed a little bit to Lester. It's his idea. He'll be a majority partner, but.
Rick, 5 ways?
What's that?
5 ways?
Okay. So stay tuned for the Kickstarter project.
Sonny, the angel investor.
Yeah.
You gotta come up with a better name though, the acronym is way too long.
BO. You have BO at your house?
We're open to feedback.
All right.
So thank you guys very much.
Nice job.
Awesome.